All right, had a little technical trouble, and I am just continuing this video, and you can see that I have factored on number 3, IA13, number 3, I have factored the first numerator. Now I'm going to factor the first denominator. It's a trinomial. Turns out to be x minus 2 times x minus 2. And the answer is yes. You could have recognized it as a perfect square trinomial and put x minus 2 quantity squared. I'm not going to go real slowly on factoring these, but instead I'm going to move through the factoring rather quickly. Numerator of the second, I see a common factor of 6, and I'll get 6 times x minus 2. The denominator of the second, I get x plus 2. In this problem, things change up a little bit, and they give you two answer choices to work on, and one of them shows these as the exclusions, and the other one shows these as the exclusions. So when I work on domain exclusions, all I have are these. In the first one, I have two factors of x minus 2. Well, I only have to look at it once. If x minus 2 is 0, x is 2. That's a domain exclusion. From this denominator, if x plus 2 is 0, x is negative 2. So I know that choice B is the one that I'm going to enter my simplified answer in. So now, let me get my red pen. I have an x plus 2 and an x plus 2. You might choose to do these in a slightly different order than I do, and that's fine. I have an x minus 2 and an x minus 2. I have another x minus 2 up here and down here. Don't forget to look on the diagonals and also up and down. Remember that every time you divide something out, you are leaving little ones behind. That means that you are getting a numerator of 6 and a denominator of 1, and you would type that as 6. So my answer is this product reduces to 6, and my domain restrictions are positive and negative 2. All right. Number 4, I may have a little bit more challenge with some of the factoring in this one. So for the simplifying, I have first numerator. It's a trinomial. I'm going to use trial and error for the signs. They're both minus. I need factors of 30 that add up to be 11. So how about 5 and 6? So x minus 5, x minus 6. The denominator, because the last sign is negative, I know I need 1 plus and 1 minus. I need factors of 24 that have a difference of 2, and I believe they will be 6 and 4, and I want the bigger one to be negative, so minus 6 and plus 4. That will, if I check those with FOIL, I will get this polynomial. In the second fraction, the numerator is the difference of squares, and it factors to x plus 4 times x minus 4. The denominator is also the difference of squares, and it factors to x plus 5 times x minus 5. Getting my red pen. I'm going to look on this diagonal, and I have an x minus 5 and an x minus 5. Looking on this diagonal, I have an x plus 4 canceling out or dividing out. Looking up and down, I have an x minus 6 and an x minus 6. Remember that all of these are little ones left over, and when you multiply what you have left, and you're just going to show it as a product, the numerator, you have x minus 4. The denominator, you have x plus 5. You can leave those with or without parentheses. Now I did this one in a slightly different order because I have been doing the domain exclusions doesn't matter. For the first one, I have x plus 4 times x minus 6, and that equal to 0 gives me exclusions. So if x plus 4 is 0, x is negative 4. There's an exclusion. If x minus 6 is 0, x is 6. That's an exclusion. And remember, when you're working with the exclusions, you're looking at denominator factors only. On the second one, x plus 5 times x minus 5 equals 0 will give me exclusions. So x plus 5 equals 0 gives me x is negative 5. There's an exclusion. X minus 5 equals 0 means x is 5, and there's a domain exclusion. So I have 4 domain exclusions. So I will choose A. My answer is x minus 4 over x plus 5 with domain exclusions of, doesn't matter about the order, negative 4, positive 6, negative 5, and positive 5. Once again, doesn't matter about the order. The exclusions come from the denominators before any canceling or dividing out takes place. Let's look at number 5. I need to factor these, so I will be simplifying. And when I get the factors, I'll probably jump over here and do the exclusions by looking at only the denominators. So here we go. This one times this one. Now y to the third plus 512, I believe, is the sum of cubes. So let me grab my calculator. Let that load. I should have had it ready. Sorry about that. So I will do math. Choice number 4, cube root 512, enter. And it is indeed a perfect cube, and its cube root is 8. So the factors of this, because it's the sum of cubes, we're going to have a binomial times a trinomial. The cube root of y to the third is y. Keep the sign. The cube root of 512 is 8. For the first term here, it's square it, so y squared. Change the sign. Product, which is 8y. Square the last one. 8 times 8 is 64. It's always plus. The denominator of the first one, and it doesn't matter whether you look at it up here or look at it down here, it's the difference of squares, so that's much easier. That's going to be y plus 8 times y minus 8. Second fraction has just a y minus 8, which cannot be factored. The denominator is 3y, which cannot be factored. So let's see what I have that's alike. I have a y minus 8 and a y minus 8. I have a y plus 8 and a y plus 8. I hope you remember that the trinomial you get when you factor the sum or difference of cubes can never be factored any further. So that's finished. I'm finished with that. What I have left over in the numerator is y squared minus 8y plus 64, and in the denominator I have 3y. Now, I don't get my exclusions from here. I get my exclusions from all of this. So, y plus 8 times y minus 8, if it is equal to 0, you've got an undefined value. So those are going to represent my exclusions. If y plus 8 is 0, y is negative 8. Let me rewrite that. If y minus 8 is 0, y is positive 8. That's a domain exclusion. It makes a denominator equal 0. That's a domain exclusion. It makes a denominator 0. The other one comes from this denominator. If 3y is 0, you could divide by 3, or just look at it and say, yes, 0 is the domain exclusion. My simplified form is y squared minus 8y plus 64 over 3y. And my domain exclusions are negative 8, positive 8, and 0. One last time I want to remind you, domain exclusions come from setting the denominators of all the fractions into factored form into 0 and solving those. That's where you get your domain exclusions.